Okay, greetings to everyone. Dear authors and invited guests, welcome to the technical session 2C. Myself, Gargi Kalra, and this session will be moderated by me. On the behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 7th World Conference on Smart Trends in Systems, Security and Sustainability World S4 2023, London, UK. The 7th edition of this conference is being organized in a hybrid mode. The physical event was held in London, UK on 21st of August 2023, and the virtual event is being organized through Zoom today and tomorrow, that is 23rd and 24th of August 2023. I hope you will enjoy the knowledgeable and interactive through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for the questions and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected throughout the session. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair of the session. Firstly, we have Dr. Meenakshi Memoria. She did her PhD in computer science from SGVU Jaipur, Rajasthan. She completed her research on fault tolerance in grid computing. She has 17 years of teaching experience in different academic institutes. Presently, she is in Uttaranchal University as an associate professor, and her research and teaching interests include machine learning, grid computing, theory of computation, compiler design, operating system, intelligence system, data structures, and etc. Meenakshi ma'am, welcome. And if you want to say something to the audience, then you can. Meenakshi ma'am, are you there? Okay, no issue. So next we have Professor Dalia Magdi, working as an associate professor at CIC Canadian International College. She did her PhD in Management Information Systems from CEDIT Academy for Management Sciences. She has head of Information Systems Department in the French University in Egypt. She is a co-director of the CRI Research Lab and associate professor of Management Information System. We welcome you to the session. Ma'am, are you there?
Yes, I'm here.
Ma'am, would you like to say something to the audience?
Yes, I want to thank the group of Congress for giving me this opportunity to share this important session, and I hope all the success and for all the researchers with us. Thank you.
Okay.
Hello, can you hear me?
Yeah, thank you so much, ma'am.
Thank.
Okay, so next we have, let's start with the presentations. So firstly, we have the paper title, Artificial Intelligence in Countering Disinformation and Enemy Propaganda in the Context of Russia's Armed Aggression Against Ukraine. And the author is Marina Tolmak. You can share your screen and start the presentation.
Good afternoon. My name is Marina Tolmach. I am from Ukraine, from Kyiv National University of Culture and Arts. And today I will present you our paper about artificial intelligence in countering disinformation and enemy propaganda. Our paper analyzes how the Russian Federation employs disinformation and propaganda in its hybrid war against Ukraine, and how and what role artificial intelligence technologies play in creating, spreading misinformation and propaganda, and at the same time fighting against this phenomena. The war of the Russian Federation against Ukraine is commonly referred to as a hybrid war due to the close relation between Russia's conventional information and cyber attacks in Ukraine. This conclusion stems from a study conducted by Ukrainian authorities, which aimed to analyze the connection between different types of Russian attacks and the events from 2022. Russian war against Ukraine has many dimensions: conventional, economic, cyber, informational, and cultural. Only understanding these dimensions interaction allows for assessing the aggressor state's actions adequately. The European Union's Foreign Affairs Service designated Russia as a primary source of disinformation in 2022, as outlined in their report. Russian propaganda endeavors to portray Ukraine as a Nazi state, leveling accusation of genocide and citizen murders while propagating false narratives about the presence of USP laboratories in Ukraine, likely engaged in developing biological weapons, specifically targeting Russian DNA. The Russian Federation has been engaging in cyber warfare against Ukraine for a prolonged period, and the spread of propaganda and disinformation has played a significant role in it. For instance, after the initial shelling and destruction of the energy sector of Ukraine, which was continuously under attack from missiles and kamikaze drones, Russian propaganda blamed the power outage on the tricks of the Ukrainian authorities instead of rocket fire. And you can see on the slide the other facts from Russian propaganda about blackouts in our country. Russian propaganda and disinformation operations actively engage in extensive dissemination through numerous channels encompassing both online platforms and traditional medias. Russian actors employ diverse strategies to present, reinforce, and propagate false and distorted narratives worldwide. These efforts rely on a combination of fake and artificial accounts, anonymous websites, and official state media sources to effectively disseminate and amplify content that serves Russian interest. Doctrinally, Russia often considers cyber and information dimensions as a single information confrontation domain. This confrontation can include either pure information campaigns or something more complex. In Ukraine, governmental and public organization actively operates. Normative documents are being implemented to regulate the digital environment and prevent numerous abuses of freedom of expression and information terrorism. Thus, the activity and close interaction of the considered and other state and public initiatives in Ukraine became an obstacle to the systematic and purposeful attempts of the Russian Federation to undermine the political and social structure of Ukraine by spreading propaganda, misleading exaggeration, and lies. The rapid development and spread of digital technologies led to the appearance of fakes and disinformation. Their creation has reached a high level largely thanks to artificial intelligence technologies. Yes, you can use AI to create fake videos, photos, audio, and other content. In most cases, the human eye cannot distinguish true information from fabricated information. AI systems exacerbate the problem of disinformation not only by increasing their ability to create realistic fake content, but also by essentially facilitating the spread of misinformation to target audience. While one neural network is trying to find out how real the photos are, the other is changing them. That is, there is a so-called struggle between the two sides of the neural networks, where one network tries to bypass the other, which in turn learns to prevent it. To protect yourself from harmful information, you can use critical thinking or technologies. At the same time, artificial intelligence-based tools allow you to effectively distinguish between organic and coordinated content distribution, detect automated spam distribution systems, evaluate the impact of different social media user accounts on the audience, and distinguish between bots and real users. In Ukraine, the capabilities of artificial intelligence systems are used to monitor the media space and analyze a large volume of online publications. The Center for Strategic Communication and Information Security uses the semantic force and attack index platforms. Semantic force employs AI as a part of its semantic analysis tool, which helps to identify information needs, trends, track changes in social networks, user reactions to events, and detect hate speech and other negative phenomena. In addition, neural networks are used to analyze images in detail to quickly identify inappropriate or harmful content. Ethic Index uses various methods. Machine learning allows to assess the tonality of messages, rank sources, and predict the development of information dynamics. Cluster analysis is used to group text messages, detect of plots and form plot chains. Computational linguistics helps to identify stable phrases and narratives. The formation, clustering, and visualization of semantic networks determines connections and nodes and build cognitive maps. Correlation and wavelet analysis detects information operation. Thus, according to the researchers, the proliferation of artificial intelligence introduced three critical changes that increase the scope, scale, and effectiveness of today's disinformation campaigns. One, artificial intelligence, which use advanced algorithms and social media data to precisely target segments of the electorate, provides a tool for micro-targeted use of existing political problems. Two, AI has made it possible to automate political propaganda, an example of which is the use of banners, etc. Three, the ability of artificial intelligence to integrate machine learning and neural network capabilities to produce persuasive AI-generated propaganda that look real. So what the conclusions? Artificial intelligence systems used for the malicious creation and large-scale dissemination of disinformation create numerous challenges for Ukraine. This is because the current war is not limited to open armed aggression, but also penetrates through various information gaps, looking for a new way every time. Online platforms are using artificial intelligence to increase user engagement with sensational and controversial misleading content. However, AI can also be used to detect fake news and promote accurate information and fight the spread of misinformation on the internet. Therefore, artificial intelligence is simultaneously used as an effective tool for detecting fakes and spreading reliable information. Artificial intelligence methods increase the phenomenon of misinformation on the internet in two ways. First, by opening up new opportunities for creating and processing text and images, audio or video content. The second, by contributing to the effective and rapid spread of misinformation on the internet due to the efforts of the subject to increase the user engagement on online platforms. This had led to the emergence of the problem of disinformation and its complications. The peculiarity of the problem is that the widespread information deliberately misleads with the aim of manipulating people, and secondly, its authors use the advantage of modern communication and information technology to achieve his goal. In this context, it is essential that military doctrines must be adapted to modern challenges, using the lessons of the Ukrainian-Russian war for forecasting and modeling. It is wise and extremely necessary to limit authoritarian regimes' access to modern technologies by strengthening sanctions, particularly in the most important areas of the economy in such regimes. It is crucial to bring international humanitarian law into line with modern realities, in particular to equate cyber attacks with war crimes. This is the way that Ukraine has chosen, which studies and effectively opposes disinformation and propaganda activities of the Russian Federations. Ukraine will continue to strengthen its resilience to Russian disinformation during the war and to counter it in the future. Thank you for attention. Stand with Ukraine.
Thank you so much, Marina, for your presentation. If anyone is having any questions, then you are open to ask.
No questions.
Okay, no issue.
Thank
you so
you.
much.
Actually, I don't have any question, but I want to thank the researcher for putting our hand on the importance of artificial intelligence, especially in this political case. Yani. So thank you, and I hope you good luck.
Thank you.
Okay, thank you so much. So let's move to the next presentation. The next we are having paper title, Development of Smart Pole System Utilizing Arduino Technology and the Internet of Things. And the author is Jason. So are you there?
Yes, I'm here.
Yes, you can start the presentation.
Okay. To our session chairs, dear co-authors, and to everyone here, good day and mabuhay. So I am Mr. Jason Albertuccio to present our research project entitled Development of Smart Pole System Utilizing Arduino Technology and the Internet of Things. With me in this research is Mr. Mike Philip T. Ramos, Mr. Andres R. Dicedo, Mrs. Jocelyn Opadalian, Mrs. Glenda D. Balatibat, Mr. Joseph Alexander E. Lapinit, Mr. Jean-Marc B. Catedrilla, and Mr. Leonardo R. Azor. And we're from Laguna State Polytechnic University, Los Baños Campus, Philippines. To begin with my research, here are the keywords of our research project. So number one is the Internet of Things. It's a network composed of devices with functionalities and software which allowing them to exchange data online. Followed by ESP32 camera is a board that combines the capabilities of ESP32 microcontrollers with camera module. The next one is smart pole system. Is a modern street light with integration of different devices and technologies connected to the internet. The next one is Arduino Uno CH340G is a USB to serial converter chip commonly used with Arduino boards. Next one is solar panel. Is a device converting solar light into a electrical energy. And the next one is Industry 5.0 is artificial intelligence concept that aims to enhance the intelligence and the connectivity of industry using IoT. So here is my introduction. Traditional street lights serve as many purposes, like community security, extending activity hours, and enhancing security to our pedestrians and riders. So according to our research, there are 300 million street lights are outdated. So these millions of street lights consume significant energy that result in global warming. So there are 5 industrial revolution that has been introduced worldwide. So it composed of 5 eras. So each eras has different integration of technology. So in my country, the Philippines, so we are in the midst of the fourth industrial revolution. So there are several researches that several countries facing challenges in transitioning 4.0 to 5.0. So Industry 5.0 uh, is an intelligent concept that aims to enhance the intelligence and connectivity of industries by using the concept of Internet of Things or IoT. So IoT, it is a vision of future where our industry is more innovative and interconnected through integration of devices and software, allowing them to exchanging data via internet. So additionally, IoT has become popular area of research in recent years. So enhancing the quality of life of citizens is the significant concept of smart cities. So to achieve the future smart cities, a range of technologies are essential like machine and deep learning, IoT, mobile computing, industry 4.0, and even robotics. So based on our research, there is a growing urgency to implement these technologies that streamline to city governance, management, and quality of life for residents. And one of the example of this is smartphone. So smartphone is an integral part of smart city concept. So in response to the challenges associated the traditional street lights and the capabilities offered by IoT platforms, so with the team or researchers conducted the research. So specifically, our study aims to develop a smartphone system to reduce energy consumption compared to traditional street lights, to improve emergency response within the community, and to enhance sustainability and safety in urban environment, to facilitate real-time data exchange by implementing of the IoT. Methodology plays a crucial role in the project development that includes data gathering, project development, and other research strategies. Our study utilized the software prototyping model. So this approach established a strong basis for the research and allowed for effective decision making regarding design. So through this methodology, we easily identify the resources, strategies for the best performance outcome of the project. So here is the concept diagram of smartphone system. So it composed of control server, Internet of Things, and our project smartphone. So under the control server, it managed by the user. So the user managed the Android application that it composed of different application module. The application can monitor the surroundings and can turn it on off the light. So the Android application or the user can receive a notification from the smartphone if the power interruption is occur and when is somebody press the buzzer button. So our system architecture is composed of 2 modules divided by 2. So modules for Android application managed by the user and modules for the smartphone and connected via Internet of Things. So, the smartphone is designed through the use of solar panel. So the solar panel converts the solar energy or the solar light into a electrical energy. So attached to the solar panel, we're gonna see the ESP32 camera, ESP32 camera with module, camera module. So we're gonna see also the LED lights. And at the middle of the smartphone, we're gonna see the power system management, which composed of solar controller, the battery, and the Arduino board. So here is the block diagram of the smartphone. It combines components such as power management, solar controller, batteries, light, and camera. So this diagram guides the team on how electricity is properly distributed to other components. So in the process of project testing and debugging, various tests were performed to identify the possible problems of the project. So this includes unit testing, integration testing, system testing, and acceptance testing. For the result and discussion, so during the test case for testing, so the team used WS4 software to assess and test the application behavior. So after our assessment using WS4 software, the result for the to the test duration produced past result. So the integration of the Android application and the smartphone was evaluated through a test case. The result demonstrates successful execution of all commands from the application of the smartphone. So this table displays the test cases conducted to assess the functionality of the smartphone. So the result indicated that all system connections are fully operational by delivering expected outcome. So this confirms that the smartphone and the server are capable of exchanging data seamlessly. So here is the compatibility assessment for light and camera. So the findings indicate that the 220 volts to 240 volts light is unsuitable for the extended usage due to the limited capacity of the 12 volts battery. In contrast, the 07725 camera module is highly recommended due to its superior compatibility with the system. So for the Android applications specifications, so the result indicate that developed application is incompatible with the Nougat version. And the latest version, and below the latest release version, to fully utilize the system capabilities, it is advisable to run the application on Android version Oreo and above. So for the conclusion, so the combination of light and camera and SOS button with IoT-powered smartphone establishes a safe environment. So contrasted with traditional street lights, this method helps lower energy usage, contributing positively to the country's environmental impact. So IoT technology enables the smartphone to establish seamlessly real-time data exchange, contributing to Industry 5.0 integration of advanced connectivity and data-driven processes. So for the recommendation, for optimal utilization of the system potential, it is advisable to use Android application on a Android version of 10 or above. So the smartphone performance can be improved by using a higher battery voltage to incorporate more advanced lighting specification. So for the camera modules, proper functioning is advised to securely store recorded videos for easy retrieval when needed. So adding multiple sensors to the smartphone enhances its potential capabilities and its capacity to create a faster and more supportive environment. So that is the end of my presentation. Here is my reference. Thank you very much.
Thank you, Jason, for your presentation. If anyone is having any questions, then you are open to ask.
Thank you. Thank you for the presentation.
Thank you. Thank you, ma'am.
Okay, thank you so much. So let's move to the next presentation. And the next paper is Machine Learning Assessment of Battery State of Health. And this will be presented by Stephen. You can share your screen and start the presentation.
Thank you, Ms. Chairman. I'm just going to share my screen real quickly. I hope it can be seen on your side as well. Good evening, good day to everyone. My name is Stefan Izanov. I would like to present to you our paper titled Machine Learning Assessment of Battery State of Health. It's a joint work between the Technical University of Sofia, Bulgaria, and the Plovdiv University of Paisy Hilendarski. The author's team is Anna Stoinova, Nadezhda Kafadarova, Sutir Sutirov, Borislav Bonev, and me. So let me first start initially with the motivation behind our work, with the increased demand for computationally powerful electronic devices, portable electronic devices, and the push towards electrical vehicles. There has been an increased demand for automated means for evaluating the battery state of health, especially for third-party supplied batteries due to their somewhat unfamiliar origin. Our other motivation behind our work is that the field of machine learning, being part of the huge interest within the scientific community for the past 15-20 years, has advanced quite a lot, and its utilization has expanded dramatically within various fields of industry. So we wanted to apply these machine learning advancements within the field of battery state of health assessment. So where did we start? We started with developing a custom battery aging system, ARM Cortex microcontroller board, which performs charging and discharging controlled cycles of batteries. The batteries you can see they're attached, which are 18650 lithium-ion batteries. The device walks the cell voltage, cell current, and infrared temperature of the batteries into a local PC, which with this data being further available for analysis. For our work, for this work that I'm presenting, we subjected 12 18650 batteries to 100 aging cycles. These are the captured data, transient data examples. As you can see, we limited the extent at which we observe the charging current, charging voltage, and discharging voltage curves, because for our analysis, we wanted to limit this data. As you can see, there are noticeable differences between these curves. So the task was, how should we convert this transient data in a manner which is appropriate for creating a data entry suitable for machine learning algorithms for analysis. So what we essentially did is we applied curve approximation algorithms for each of the three curves, with us employing 4 different kinds of approximation: a power, polynomial, exponential, and Gaussian approximation of the second order, which each of them outputting a set of parameters. The set of parameters for each of the approximations in each of the three curves as a whole makes up a single data entry, which we used for our machine learning algorithm. In order for us to analyze this data, we decided upon creating a machine learning classifier, which essentially, whose goal is to essentially split up the data into 2 parts. Batteries subjected to aging cycles below 50 are categorized as being new or non-aged, and batteries subjected to over 50 aging cycles are considered old or aged. So as you can see here, this is the output data and the parameters and their data spread. which we use for our machine learning algorithm, in order for us to verify whether our data is properly structured, we utilize some scatter plots. As you can see, the different parameters and class affiliation is designated as being of different color, red and blue appropriately. Correspondingly, so as you can see from these scatter plots, the parameters, even though they are part of the different approximation algorithms and different curves, there is noticeable clustering and linear separability in our data, which is crucial when developing a machine learning classifier such as the one that we intended to build. We had an interest towards several different kinds of classical machine learning algorithms, such as you can see, complex decision trees, linear support vector machines, quadratic support vector machines, fine k-nearest neighbor, ensemble boosted trees, and ensemble subspace discriminant. We evaluated first as a function of cross-validation folds. As you can see, the accuracy which we managed to perform was in the range of 90 to 95%, with the poorest classifier being the subspace discriminant and k-nearest neighbor. As can be seen, the best performing classifiers were ensemble methods, which is somewhat predictable due to their higher accuracies. Then we evaluated the data and trained different these models, machine learning models, as a function of holdout percentage. As you can see, when the holdout percentage is increased up to 35%, even the ensemble methods reduce their accuracy, but they are most durable in this for this data, with the ensemble boosted trees methods showing to be most accurate. This 100% accuracy is somewhat suspicious from our point of view, most probably due to a slight overfitting over the data. But as a general observancy, we can see that an accuracy of above 90% is achievable through these different types of models. Misclassification, as can be seen, varies depending on the model, support vector machines and k-nearest neighbor. As you can see, k-nearest neighbor misclassifies more data entries in respect to support vector machines. We also generate a set of ROC curves. You can see that the area under the curve for linear SVM is about 0.97, for a k-nearest neighbor is about 0.94, and for an ensemble subspace discriminant is about 0.91. Also, here you can see the corresponding confusion matrices for the machine learning models that we developed. And lastly, we wanted to propose and develop methods which converts the transient captured data for the cell voltage current during charging and discharging, and converting them into images by means of spectrogram analysis. As you can see, for the different cycle numbers, these spectrograms vary quite a lot, which makes it so that these images can essentially be used as a digital signature for each battery, depending on the number of aging cycles. And in this way, converting the transient data images into spectrogram images, these images can be used as data entries for the training of an image classifier, such as a convolutional neural network for the evaluation of battery state of health. So this way, we converted the evaluation of state of health of batteries into an image processing and image classification task. And this was our work essentially for this paper. We presented novel methods for evaluating the state of health. We employed different machine learning algorithms, and we proposed and developed a spectrogram conversion method for converting the transient data and making it appropriate for image analysis through convolutional neural networks. This project was funded and part of a research project within our two universities, which we participated. And on the behalf of the whole authors team, I would gladly like to express my gratitude for your time and attention. Thank you.
Thank you, Stephen, for representing your paper. If anyone is can ask. Anyone having any questions?
No, actually, I don't have any questions, but many thanks to the team of researchers who has made this great job, which may be very important in our day-to-day life and especially in the health field. Thank you.
Thank you very much.
Hello. Stefan, I was really very impressed by your presentation. Actually, you have explained everything. Even you have shown the results. In previous paper, I think the author was not able to show the result, but you have shown everything, whatever you have implemented in that. So it's good presentation. Nice.
Thank you. Thank you.
Okay, thank you so much, everyone. So let's move to the next presentation. And the paper is Prediction Techniques Applied to Gold Price Analysis, a Comparative Approach. And the author is Percy. Are you there? Is the presenter there?
Yeah, just a second, please.
Okay. You can share your screen and start the presentation.
Right. Okay. Good afternoon, everyone. It's a pleasure to be here today to introduce a paper that holds great significance in the realm of financial analysis. The paper is titled Prediction Techniques Applied to Gold Price Analysis, a Comparative Approach, authored by Oscar Infantes, Aima Persson, Percy Woman. So let's move to the next. So let's start with a little introduction about the oscillation of gold prices. For generation, this precious metal has suffered solace to investors amid economic uncertainty and market instability. Its intrinsic value to inconsistent demand across industries like jewelry and electronics make gold prices a barometer of economic stability and market trends. In our modern era, accurately predicting gold prices has become an intricate challenge that affects not only investors, but also companies and financial analysts. The gold market's inherent volatility leads to rapid price swings within short spans. Moreover, worldwide economic factors, including political stability, interest rates, and macroeconomic conditions, directly impact gold's valuation. So constructing a precise gold price prediction model carries profound implications for both investors and the industry at large. Investors can harness these predictions to make informed decisions about their gold holdings, adapting strategies accordingly these measures. An accurate model helps identify buying and selling moments and better manages the risk of gold investment. That's why our mission is scrutinize and compare various approaches that are linear regression, super vector regression, and regression trees to discern the most accurate gold price predictor. So after establishing the foundational theory and gathering pertinent data, an intricate systematic methodology was formulated. This methodology encompasses a comprehensive flowchart that outlines the pivotal stages required for the creation of customized predictive models, especially aimed at estimation of gold prices. Informed by a meticulous examination of analogous research endeavors, this meticulously designed flowchart ensures lucidly comprehensive guidance. Furthermore, a comprehensive exposition of the tools harnessed throughout this methodological journey was furnished, thus upholding the study commitment to transparency. So let's delve deeper into our methodology to get development of predictive model employing supervised learning techniques. A meticulously crafted flowchart was employed, influenced by prior studies. This comprehensive chart illustrated in this figure serve as a visual representation of our process. And we elaborated on certain aspects of this article, exemplifying their application in specific research cases. It's imperative to note that this flowchart establishes a preliminary order for the model development using machine learning algorithms. However, it's not uncommon for interaction between steps to occur after initial results are obtained, enhancing and refining outcomes. This underscores the inherent flexibility and adaptability in the predictive model development process. So now moving to the first section. The process begins with a problem definition, a cornerstone of our approach, identifying a machine learning technique suited to address a specific problem that is pivotal. As it lays the foundation for subsequent steps. This categorization unfolds in two phases. The first, we classify based on the data inputs. If library data dictates the desired response, we are dealing with supervised learning. In contrast, when data lacks labels aims to uncover patterns or structures, we venture into unsupervised learning territory. Furthermore, if optimizing an objective through environmental interaction is the goal, we venture into reinforcement learning reinforcement learning. Subsequently, we categorize problems according to output. If a numeric value is desired, we confront the regression problem, and classification problems arise when expected output corresponds to a category. Lastly, anomaly detection is employed to identify the outliers in the data. In our study, we employed a supervised learning approach to predict the gold prices, utilizing continuous and established data for both input and output. Given our intention to predict numerical values, our problem is regression 1. We consider various predictors variables like the dollar price, the US Federal Reserve interest rate, the US GDP, work production, and other relevant factors. And our chosen measurement metric is the root mean square. Here. Turning to the data collection phase, we embark on gathering essential information over the last 5 years. We've meticulously amassed data at inter-daily frequency. This task was challenging due to the limited availability of such frequency in certain reports. With data sourced from reliable outlets, our selections prioritized relevance to the study. This data was methodologically collected and subsequently integrated into a specialized database for further analysis. Continuing on data preparation, initially a meticulous data cleaning process takes place to address outliers, missing data, and inconsistencies, ensuring the integrity of the dataset. Subsequently, data is explored and transformed through statistical and visual analysis to point key relationship and patterns. Essential attributes are thoroughly selected, and techniques like scaling and coding are applied to optimize prepared data for machine learning. Also, the Pearson correlation table becomes an essential tool, allowing the examination of relationships among variables relevant to gold prices. Following through data preparation, this metric is computed visually representing the strength and direction relationship. This analysis unveils significant patterns, identifying variables closely like the gold prices, holding the potential to be fundamental predictors in the resulting model. On that analysis stage, we grapple with the challenge of forecasting time series, considering the intricate nature of variables and the inherent problem at hand. Our objective revolves around predicting the gold price, which serves as the dependent variable, while various other variables play the role of independent factors. This endeavors entails the application of machine learning algorithms that leverage an array of input data to formulate forecasts. Throughout this process, preserving the chronological order of variables is paramount, as temporal changes can significantly impact the data relationships and patterns. The data partitioning is executed with a strategy of precision. Roughly 75% of the data is allocated to the training set, leaving the remaining 25% evenly distributed between the cross-validation and the test sets. This distribution strategy is a well-balanced compromise, providing models with sufficient training data to comprehend the problem complexities while maintaining independent data sets for the invasive evaluation of their performance. This meticulous approach to data partitioning underpins the creation of sturdy and dependable models, equipped to accurately predict future gold prices. On the modeling phase, three distinct models were meticulously tested against the backdrop of our collected database. Our investigations commence with a linear regression model that is a foundational exploration for our dataset's potential. This model serves as our initial benchmark, offering insights into the capabilities of machine learning algorithms when it's introduced to the novel data. Its simplicity makes it an ideal.
Sorry to interrupt you, Percy.
Yep.
Actually, 10 minutes are about to complete, so let's conclude the presentation.
Okay. Offering insights into the capability of machine learning algorithms when introduced to the novel data. It simply makes an ideal starting point, granting us glimpses into our datasets. Transitioning to the more intricate supervector regression model, we venture into the realm hyperparameters, fine-tuning. This process involves the cross-validation coupled with the grid search techniques. And then we went to the tree model. That is a versatile choice brimming with advantages, and it excels in its easy interpretation, adept handling of distribution data, and the resilience in the face of outliers. So going to the results, our dedicated efforts have culminated in the pivotal phase of assessing our predictive models. We gauge their performance using the metrics such as the mean absolute error, the truth mean square, and the R2 score. And these metrics as yardstick for measuring accuracy and model fit against our test data, offering valuable insights into their effectiveness as we turn attention to the specific outcomes. And we find that our chosen model, linear regression, the regression tree, and the SBR have yielded the following results. So as a conclusion, the transition into the implementation phase, we bridge the theory with practice. The moment our model finds real-world application, we select new data samples that were not part of the training sets, representing fresh scenarios where gold price predictions are required. These samples encapsulate vital variables such as economic indicators that were political influence and unique events that could sway gold prices. And using our well-honed model, we apply this input data to generate predictions, drawing the model's learned patterns during training. It delivers estimates funded and historical relationship between these variables. So that would be it. Thanks.
Thank you so much for your presentation. If anyone is having any question, then you can ask.
Thank you. Thank you for the nice presentation. Thank you.
Thanks.
Okay, so let's move to the next presentation. And the next paper is again from Stephen. The paper title is Self-Organizing BLEM Drones for Wildfire Detection.
Thank you again. I'll just share my screen with you again. So good day to everyone again. This paper titled Self-Organizing BLEM Drones for Wildfire Detection is with an author team, Professor Peter Yakimov and me from Technical University of Sofia. So again, let's start a little bit with our motivation. There is, due to the non-material and material damages that forest fires inflict upon the population, there is an increased scientific interest towards solutions for early detection of such events. There has been also propositions for developing fleets of drones, and we want to investigate the opportunity to develop a blimp-based UAV, whose goal is to participate in a fleet of self-organizing such drones for wildfire detection. Contemporary UAV systems, unmanned aerial vehicle systems, have several deficiencies, as can be seen here. They suffer from limited scalability due to the direct involvement of operators and subjective factors such as operator fatigue, day-night cycles, etc. Due to their operation and in order for them to support their flight, they consume high amounts of energy, so that due to them being battery powered, this drastically limits their operational lifetime. There are stability issues for contemporary UAVs when operating in the vicinity of wildfires due to the warm air. There are strict regulatory limitation and restrictions regarding which part of the airspace is usable when operating in a wildfire environment and operating in proximity to government buildings and military bases, etc. Also, due to their small sizes and limited battery life, they are not capable of carrying large payloads, so the sensory elements for such UAVs are computationally limited and are not very powerful. This is why we propose the construction of a blimp-based UAV system. As you can see, this is a graphical representation. a fleet of such blimp UAV systems can be constructed. With blimp drones, their main advantage being that they can support their flight operation without consuming energy, and energy can be consumed only for drone direction and data acquisition and processing of the sensory units. Additionally, employing wireless communication and energy harvesting, this system can be essentially made to be quite smart and intelligent. As can be seen, blimp drones are comparatively less complex and can be produced in higher volumes and with relatively more cheaper than contemporary UAVs. Energy harvesting such as solar panels can be used to prolong the operational lifetime and allow for larger, more complex sensory payloads to be carried due to the lower power consumption for flight sustainability. And such a solution has an increased scalability of deployment. What we did is we developed several UAV hardware modules, a master controller block which has two versions, with a GPS module and without a GPS module, and an infrared sensory module. The master controller block is fitted with several environmental sensors, as will be shown in the next slide. The infrared sensory module is fitted with infrared microgrid infrared camera sensor, 8x8 pixels, able to detect active flames, and also a narrow band CO2 sensor. So what is in the master controller block? There is a ARM Cortex STM32 microcontroller, a water transceiver module, a GPS module, and several environmental sensors such as a CO sensor, CO2, formaldehyde, temperature, humidity, pressure sensor, and air quality sensor. These parameters influence when the accuracy in capturing thermographic images. So essentially, they can be used for correcting the captured data and also to capture the ambient conditions for operation. The master control block, as I said, contains the following modules, and the infrared sensory module contains a microgrid infrared imaging sensor and a narrow band infrared spectral line sensor tuned to the CO2 emission line. In order for us to automatically detect wildfires in infrared images, we constructed image object detection algorithm, whose structure in a pseudocode representation can be seen here, by detecting contour pixels in a thermogram and then defining, depending on the contour pixels, where the object is within the thermogram. We performed some preliminary tests with our system with a small controlled in a laboratory environment wildfire without additional optics. We found that evaluating the presence of wildfires with this small microgrid infrared sensor is possible to around 5 meters without applying optics. With additional optics, we can increase considerably this distance for detection due to the limited sensitivity of the sensor. We approximated these curves at different distances. These are the curve approximation coefficients, the R-square metric, SEC metric, adjusted R-square, and RMSE metric, as can be seen. We also additionally proposed how such a system would, such a network would be organized. We proposed a water mesh network connection for inter-blimp communication. The local coordinator within such a mesh system should be located always within the mass center or along a topological symmetry line within the network cluster, or its location can dynamically and randomly be changed. This is done in order for optimal electrical load bearing to be provided for the whole network. Additionally, we investigated and proposed a hybrid quality of service and energy efficiency optimization method, in which within the mesh network, optimal data paths are those through which data aggregation rates are the highest. And additionally, computationally challenging tasks are dynamically allocated towards devices which have larger available stored energy resources in order for such a system to be operational for a prolonged period of time without the direct intervention of operators and to operate in an autonomous manner. In conclusion, we present in-depth discussion regarding UAV specifics within our work. We developed and presented two prototype modules, a water master controller block and a microgrid infrared sensory module. We performed some preliminary proof of concept tests regarding the automated detection of wildfires through small microgrid infrared imaging sensors. And we present the proposed communication network structure and how such a system can be made in order for it to operate in a self-organizing manner. And again, on the behalf of the whole Outdoors team, I would like to express my gratitude for your time. Thank you.
Thank you so much for your presentation. If anyone is having any questions, then you can ask. Anyone having any questions?
Thank you. Thank you for the presentation.
Thank you.
Okay. So thank you so much. Now let's move to the next presentation. And the next paper title is The Winning Edge, Dominating the Game with a Hybrid Content-Based Cricket Scenario Recommender System. And this will be presented by Sanathan Bhargav. Are you there?
Yes, I am there.
Yes, you can start the presentation.
Okay. Greetings, session chairs, and everyone else present in the room. This is our presentation for WS4 2023. The title of our paper is The Winning Edge, Dominating the Game with a Hybrid Content-Based Cricket Scenario Recommender System. The authors include myself, Sanath, Samarth, Sankar Rohan, and our guide and mentor throughout this paper, Professor K.S. Srinivas. So throughout this presentation, we will discuss the data sets we have used, the models that we have used, the method, the results that we have obtained, the future scope of our research, followed by the conclusion. So let's get started with the introduction. Our proposal involves a hybrid recommender system that utilizes the BERT model to significantly enhance players' performance by identifying weaknesses and providing recommendations for suitable opponent bowler types. This system suggests dedicated practice sessions against similar net bowlers to effectively address these weaknesses and offer tailored recommendation for cricket shots and field placements against specific bowlers. Through targeted training and strategic guidance, this innovative system empowers players to elevate their competitiveness on the cricket game. So our statistics take into consideration the ball line, the ball length, for which the batter got dismissed on that particular delivery. In the game of cricket, the nature of the pitch assumes a pivotal role in determining ball movement, which can vary significantly depending on whether the pitch is dead, dusty, or green. Another crucial aspect is field positioning. When a bowler strategically arranges the field based on the prevailing conditions for a specific batter, the batter's goal should be to skillfully maneuver these shots into the vacant areas on the field to accumulate additional runs. This requisite skill necessitates diligent honing through dedicated practice sessions in the nets. The field conditions are also dependent on the venues. For example, the Lord's Cricket Ground in England has green pitches. The green pitches are favorable for fast bowling, and the fast bowling has considerable different field conditions compared to a spin track where spin bowling is used in prominence. For example, the Chidambaram Stadium in India. Let us go to the data sets that we have used in our paper. We have curated our own dataset, which is called StatHive, which was compiled through manual efforts, utilizing Cricket's resources such as HouseStat, CrickBuzz, CrickSheet, and ESPN Cricinfo. This comprehensive dataset offers valuable insights into ball properties and shot executions, leveraging the power of BERT. It encompasses critical ball characteristics like line, length, speed, and swing spin, considering playing conditions like day or night matches and seasonal variations. The dataset provides a comprehensive understanding of the game dynamics, including strategic choices and shot preferences of batters. It also includes 50 field templates tailored to different bowler types, allowing the recommender algorithm to offer refined and context-specific recommendations based on evolving game conditions and player dynamics. The integration of the StatHive dataset with advanced language models like BERT enriches our comprehension of cricket and facilitates exploration of the intricate interplay between various factors. So as shown here is the curation process of our dataset StatHive. We have taken data in different formats, for example, ball commentary and JSON format. We have combined them and we have taken all the listed fields shown here. This is the example of the dataset curation. We have the commentary, which is as shown here, and the fields which are extracted out of the commentary. This is a sample of the dataset. Now let us move on to the models that we have used in our paper. We have the artificial neural network, we have BERT, and we have KeyBERT. The neural network architecture used in the system consists of multiple layers that process and analyze input data. It starts with an input layer of 3 nodes, which receives and transmits the primary information. A hidden layer of 5 nodes is integrated into the network. The activation function used in this hidden layer is the rectified linear unit, ReLU, which introduces nonlinearity in our network. The architecture also includes an output layer with a single node, which utilizes the sigmoid activation function to compute values between 0 and 1, representing output probability. The chosen loss function is our binary cross-entropy loss function, as the aim of our artificial neural network is to compute probabilities between 0 and 1, and hence we need the log loss. We then move on to BERT. We have used a specific aspect of BERT, which is the masked language modeling. So this architecture involves masking a portion of input tokens at random for a deep bidirectional representation and predicting these masked tokens through the masked language modeling (MLM) process. To address mismatches between pre-training and fine-tuning, masked words are selectively replaced with the masked token, random tokens, or can be left unchanged. The replace sequence is represented as T, which is shown, and then used to predict the original tokens using a sparse categorical cross-entropy loss. The training of the masked language model aims to reduce the cross-entropy loss and enhance predictions of masked tokens, improving the accuracy of the model. So as we can see here, the BERT mask modeling architecture, we have a sequence of tokens. We mask a specific number, that means 15% of the tokens. We pass it through a bidirectional encoder, and we then pass it through a feed-forward neural network with a softmax activation function, and then make the BERT model predict the masked tokens. We then have KeyBERT. KeyBERT has many different processes, which include BERT embeddings, which utilizes pre-trained BERT for contextualized word representation. Tokenization. The text is split into tokens based on BERT tokenizer rules, each assigned an index and position. We then have contextual embeddings. BERT processes tokens to generate contextualized word embeddings that capture meanings within the text. We then have the k-means algorithm, which involves initializing centroids, assigning embeddings to the nearest centroid, updating centroids iteratively for convergence. We then have cluster representation, where centroids serve as reference vectors for their clusters. We then have keyword extraction, where keywords are extracted by finding tokens closest to cluster centroids using cosine similarity. The cosine similarity, as the formula which is shown here, measures likeness between token embeddings and centroids, with higher values indicating a higher similarity. Let us then check the method which we have used for our recommendations. The first is the refinement of the dataset. The dataset is refined to focus on a specific matter of interest, extracting insights from instances of their dismissal. Relevant data points are selectively filtered, removing extraneous information. This enhances analysis and precision, allowing for a targeted assessment of the batter's performance, leading up to their dismissal and revealing valuable insights into playing style, decision-making, and potential areas for improvement. Then, we take ball characteristics which are extracted using KeyBERT from the commentary. We clean text through tokenization. We use stopword removal and punctuation handling. We then apply pre-trained BERT model, that means keyword model, to extract crucial features from commentary. We then locate ball line references and ball length indications using keyword for length keywords and related keywords. We then spot field position references, use keyword for keywords, categorize positions. We then link ball characteristics with the specific instances. So this is a flowchart representing the flow of ball characteristics extraction from our keyword model. The next is training set generation for attacking and defending. In this, we first split data for attack and defense strategies with focus on scoring outcomes. We then define the ball attributes such as ball line and ball length, which analyze matching data. Identify the ground types, assess the outcomes on the same ground. We then use a predefined table for shot guidelines, extract the suggested shots. We then formulate structured sentences for subsets, including player roles, ball info, ground, and recommended shots. So this is the method to create our training set. We then use the artificial neural network model specified before, which takes into input the runs required, balls remaining, and wickets remaining, and predicts the motive, i.e., where the motive is 1 means the batter should attack, and if the motive is 0, the batter should defend. This is based on the scenario in which the batsman had got out. We then form the query. The query should encompass essential particulars, including batter and bowler types, ball line, ball length, ground type, season, and match type. The query format is as shown here. That is, batter type facing a bowler type against ball line, delivery of ball length on a ground during the season in the time. So each query element serves a distinct purpose. The purposes are as listed. So the query structure enables the BERT model to effectively analyze context, ensuring precise predictions for alternative shots in the given context. So this is an example showing the whole process from the commentary, keyword extraction, which has ball length, ball line, key fielding position, then shows our generated query. We then mask the query, and then we output the recommended shots. Also, the shot prediction is by using two different BERT models, one for attacking shots.
Sorry to
and
interrupt you, Sanath. I think 10 minutes are done, so I would like to request you to conclude your presentation.
Yeah, sure. Wasn't it 12 minutes, as I remember? The presentation?
Yes, you can go ahead for 2 minutes more.
Okay, thank you. So the shot prediction using masked language modeling. We have two different BERT models, which are attacking BERT and defending BERT. Feed-forward neural network, as shown below, and the prediction using the softmax activation function. We then use field placements. The cricket recommender adapts fielding based on bowler-batter pair, factoring in styles and attributes. Using player profile, it offers precise fielding recommendations, considering tendencies, rules, and match phase. With a broad strategy pool, it suggests competitive arrangements, aligning with player dynamics and match context. Let us have a look at the results. So the cricket recommender employs three models: short ANN, defend BERT, and attack BERT to enhance predictions. Each is trained on datasets. BERT models has 35,000 offense and defense queries. Fine-tuning involves 5 more epochs for BERT with cricket data. Short ANN trains for 15 epochs on 980 match instances. The model strength is ensured by a 5-fold cross-validation. So these are the results. We have chosen the model which showed best accuracy. Let us go to the future scope of our paper. We can integrate it with real-time match data. Real-time match data elevates recommender accuracy by analyzing live match data like bowling, pitch, player form, tailored suggestions stay current. Player-specific metrics improve understanding, refining suggestions. We can also integrate with video analysis and computer vision. Detailed insights into batting, bowling, strokes, and fielding enhance the tactics. We can also expand to team-level insights involving dynamics, opposition style, strengths, aiding strategy, selection, and planning. So to conclude, the cricket recommender advances player skills with custom advice, gearing them for specific rivals. By scrutinizing bowlers' traits, it pinpoints archetypes, proposing targeted training against similar net bowlers to address weaknesses. Driven by data and expertise, the system empowers adaptability, context comprehension, and readiness. Result, better performance, growth, and cricket success. Thank you. We would like to thank WS4 and its distinguished panelists for affording us the invaluable opportunity to showcase our research paper. We would also like to thank our guide, Professor K. Srinivas and PS University for nurturing us in the completion of this paper. Thank you.
Anyone having any questions?
No, thank you. I just want to comment on the time. You should for the next time you should put in mind more how you're gonna how you're gonna figure out to talk within the limit of the task. So the limit of the time, the period.
Yes, madam. I will keep in mind.
Yes, thank you.
Thank you.
Thank you so much for your presentation. So we are done with the presentations. I sincerely thank our authors for their excellent presentation contribution for the session and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the 7th version and all the 6 versions of the conference. We will be happy to have you in the 8th version in 2024. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of WS4 2023. And I would also like to thank our session chair, Dr. Dalia Magdi and Dr. Meenakshi Memoria for chairing the session, and a token of appreciation to the chair on behalf of the whole team WS4 2023 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. And at the last, I would like to ask you all to please turn on the camera so that we can take a quick snapshot. Sanath, can you please turn on your camera? Yeah, thank you. Thank you so much, everyone, for your valuable time. Thank you so much.
Thank you. And thank you for the great organization. Thank you.
Thank you so much.
Thank you.